Hello everyone. Let us solve few previous year JEE questions from the chapter waves. A uniform string of length 20 meter is suspended from a rigid support. A short wave pulse is produced at its lowest end. It starts moving up the string. The time taken to reach the support is by considering G to be 10. So in the problem said that a uniform string of length 20 meters is hanging down from a rigid support. A short pulse is produced at the lowest end. Let's say a pulse is produced at this point, and this length is L, that is 20 meters. Time taken to reach the support is, so in what time this pulse generated at the free end will reach this top of the end. So in this problem, there is variation of tension. As the pulse proceeds or the pulse moves in this upward direction, tension in the wire also increases due to its own weight. So let me write mass per unit length of the wire is, assuming the total mass of the wire is some m, so mu is m over L. Let me consider a point along the length at a distance x from the bottom. So velocity of the pulse at a distance x is equal to tension at that distance divided by mass per unit length. Now, tension at this point x can be written as mass in this distance x into g, and mass of the string in that length x is obtained. So I can write this tension at the point x as mass per unit length into distance x gives us the mass of this hanging wire in distance x into g. So substituting this value in the equation, what we get is mu x into g divided by mu. So mu and mu cancels, giving velocity equals square root of g into x. By the definition of velocity or speed, it is dx by dt equals to root of g into x, or time dt equals dx over root of g into x. I need to calculate time from this point to the top. So time is from 0 to t. So I shall integrate this term to get total time for the travel of the pulse from 0 to L, 0 to t dt is equal to g is a constant, so root g into integral 0 to L 1 over root x dx. So integral on the left hand side gives me time, total time t. On the right hand side, it is root g into the integral of 1 over root x will be 2 times root x between the limits 0 to L, that is 20 meters. So let me substitute the values. T equals to 2 times root of, what do you have here is L by g, and value of L is 20 meters, g is 10 meters, so that is root 2. So answer is 2 root 2 seconds. Option B is correct. Next question. A sonometer wire of length 1.5 meter is made of steel. The tension in it produces an elastic strain of 1%. What is the fundamental frequency of steel if density and elasticity of steel are 7.7 and 10 power 3 kg per cubic meters and 2.2 into 10 power 11 Newton per square meters respectively? So length of the sonometer wire is 1.5 meters. The tension, let it be T. Due to this tension, there is an elastic strain, so length increases by 1%. So we can write strain, which is change in length by original length, as 1%, which is 1 over 100. What is the fundamental frequency of steel if density and elasticity are given? So density rho is 7.7 into 10 power 3, and elasticity, that is Young's modulus, is 2.2 into 10 power 11 with the proper unit. We know that fundamental frequency in a stretched string is equal to 1 over 2 times length into tension by mass per unit length, or rho into A, density into cross-sectional area. But cross-sectional area is not given, tension is also not given. So from the given value of Young's modulus, we can remove this T by A and introduce the known values Young's modulus and the strain. So from the definition of Young's modulus, it is stress over strain, and stress is nothing but tension per unit area divided by the strain delta L over L. So I can replace this T by A term by writing T by A equals Y into delta L over L, that is strain in the string. So therefore, the equation becomes 1 over 2L into square root of Y times strain delta L by L divided by density rho. So now let's substitute the values. 1 over 2 times 1.5 meters into square root of Young's modulus is 2.2 into 10 power 11. And what is the strain produced? Strain is 1%. So it is 10 power minus 2 divided by density of the material 7.7 into 10 power 3. So what we get is 1 over 3 into square root of, so you can write this as 22 by 77. So that is 2 by 7. 11 2 times is 22 and 11 7 times is 77. So this becomes 10 power 6. That can be written as 1 over 3 into 10 power 3. This can be written as root of 0.28. This comes out to be 0.53 into 10 power 3 divided by 3. So this value is equal to 178 Hertz. B is correct. Next question. The transverse displacement y of x comma t of a wave is given by its exponential minus ax square plus bt square plus 2 times root of ab into xt. This represents, so the given wave is y equals e power minus of ax squared plus bt squared plus 2 times root of ab into xt. So to get a clear idea about this, a wave must be in the form of omega t plus kx. So any wave must be function of omega t plus or minus kx. So let's try to write the given equation in this form. So y equals e power minus ax squared. So I will write that as root ax squared plus root b is whole squared. So root b t whole squared plus 2 times root ab into xt. So that means it is in the form of a plus b whole square. So we can write this as e power minus root a times x plus root b times t whole square. So now we have the function in the form of omega t plus kx. So what is value of omega? Omega is root b and k is root a. Therefore, what is speed of this wave? The wave speed is omega by k. So it is root of b by a. And in what direction this wave is moving? And you need not to worry about it, as the wave is moving with this speed, and in the options, the only option is a. So the wave is in negative direction with the speed of root b by a, because Both the coefficients are having same sign. Whether you multiply this negative term inside or keep that outside, what matters is whether both the coefficients are having same sign or different. Since they are having same sign, it is traveling along negative x direction. The right answer is option A. Next question. A traveling wave represented by y equals a sine omega t minus kx is superimposed on another wave represented by y equals a sine omega t plus kx. The resultant wave is, so we have two waves, y1 equals a sine omega t minus kx, means it is moving along positive x direction, and y2 is a sine of omega t plus kx. And the resultant wave is given by y equals y1 plus y2, and that is a of sine of omega t minus kx plus sine of omega t plus kx. So sine a plus b formula can be used to get 2 times sine a plus b by 2 and cos a minus b by 2. So we get 2 times a sine a plus b. A is omega t divided by 2. So we get omega t and cos of kx. Now the question is, this resultant wave is a stationary wave. It's a standing wave because the amplitude is changing as a function of position x. Now, in the options, wave traveling along positive, a wave traveling along negative x direction. It's not a traveling wave, it's a standing wave. Therefore, the two options are C and D, but they are speaking about the nodes formation. So, node formation, we can make use of this displacement equation. Where do we find the nodes? Nodes means its amplitude must be 0. So 0 amplitude means 2 times a cos kx must be 0. This gives cos kx must be 0, which means what must be kx equal to? K times must be multiple of pi by 2. Cos pi by 2 is 0. Cos 3 pi by 2 is 0. That means odd multiple of pi by 2. So how do we write that odd multiple? 2n plus 1 into pi by 2. This is the general condition. So what is k? It is 2 pi by lambda into x equals 2n plus 1 into pi by 2. So this pi and pi cancels. Let me take lambda to the right hand side and divide by 2. So that gives us x equals n plus half into lambda by 2. So nodes are formed at a distance equal to n plus half of lambda by 2. So option D is correct. Next question. The equation of a wave on string of linear mass density 0.04 kg per meter is given by y equals 0.02 sine 2 pi into t by 0.04 minus x by 0.05. Then what is the tension in this string? So the displacement equation is 0.02 sine of 2 pi t divided by 0.04 minus 2 pi x divided by 0.05. So by comparing this with the standard equation, omega is 2 pi by 0.04 and value of k is 2 pi by 0.05. And the question is about the tension in the string. So tension can be calculated by calculating velocity. The velocity of the wave in this string is v equals omega by k, that is 2 pi by 0.04 divided by 2 pi by 0.05. 2 pi cancels. It's 0.05 by 0.04 or 5 by 4. Now we know that velocity in a string is equal to root of tension by linear mass density mu, and by squaring this I can write v square times mu equals t. So tension T equals v square is 25 by 16 into what is mu is 4 into 10 power minus 2. So what do we get? 4 times. So 25 by 4, that is 6.25 into 10 power minus 2. And there is no option. So it must be multiple of 10 power minus 2 here. So option D is correct.